Hello everyone and welcome to my channel. Find the sum of all real values of x that satisfies the equation x squared minus 5x plus 5 all raised to power x squared plus 4x minus 60 is equal to 1. Okay, fun fact, if you have this kind of equation, if it appears in your test or exam, don't skip it, you can go ahead and solve it. It's actually very simple. You see. Okay, let's just break this equation down as x raised to power n. Oh, what am I doing? Okay, x raised to power n is equal to 1. Now, I know that if you have like an equation of this form, the first thing you want to do is to take the root of both sides, then find the value of x, like you take the root of both sides, the nth root of both sides here, and find the value of x to be 1. If you do that here, that you take the x squared plus 4x minus 60th root of both sides of the equation, then solve for x, you won't be technically wrong, but you have to ask yourself, will that really give you all real values of x that satisfies this equation? Now, the answer is no, it can't. So since it can't, then we have to come back to this our basic idea we've laid out, and we ask ourselves, what are the various values of x and n? That is, what are the various values of this left hand side that when we combine them, it gives us 1. First, you know that any number raised to power 0, that's 1. Whatever number you have here raised to power 0, this is 1. So our first condition is that n is equal to 0. If this condition is satisfied, then this over here, the left hand side, will always be equal to 1. So let's solve it. Let's do that. Okay, so let's just do it. We have that our n here is this, so we just put it in. Our n is x squared plus 4x minus 60, so we are going to equate that to 0, then solve for x. Okay, factorizing this, we get x squared plus 10x minus 6x minus 60 is equal to 0. Then we factorize x out, we get x plus 10, then minus 6 comes out here, we have x plus 10, all equal to 0. Okay, then we can factor out x plus 10 because it's common here and here, so factoring that out, we have x plus 10. Okay, x plus 10 into the first term gives us x, then in the second term gives us minus 6, then this is equal to 0. Now for this equation to be correct, x plus 10 is either equal to 0 or x minus 6 is equal to 0. That gives us x is equal to negative 10 or x is equal to positive 6. And these are the values for which the index is equal to 0. Now at this point, the base might not actually be equal to 0, but whatever it is, even if it's 1 million raised to power 0 also gives us 1. So whatever the value of the base is, as long as the index is 0, this gives us 1. But is this the only answer to our problem? Absolutely not. Now, you know that 1 times 1 is 1. 1 times 1 times 1 is 1. So that tells us that 1 squared is 1. 1 cubed is 1. 1 raised to the nth power is still 1. So if you have okay, let's go to a new page, sorry. This would be our second condition. 1 raised to power anything, that gives us 1. Simple. So whenever, okay, see our base equation here. So whenever x is 1, then whatever the value of the index is, even if it's 100 million, we still get 1 as our answer. 1 raised to power anything is 1, even if it's a complex number. 1 raised to power anything is 1. So we're going to equate the base to 1, then solve for the value of x at that point. And our base is x squared minus 5x plus 5, and we're equating it to 1. We want to find all values of x for which the base is equal to 1. So we can subtract 1 from both sides of the equation, and we get x squared minus 5x plus 4 is equal to 0. Then we have x squared minus 4x minus x plus 4 is equal to 0. Now we can group. We get x over here, x minus 4 will remain in the bracket, minus 1 comes out, we have x minus 4, and all these is equal to 0. Now, since x minus 4 is present here and also present here, we can just factor out x minus 4, and we get x minus 1 left, and this is equal to 0. Now, for this equation to work, either of these must be equal to 0. So it's either this is equal to 0 or this is equal to 0. So let's do that. So if x minus 4 is equal to 0, if x minus 4 is equal to 0, then this gives us that x is equal to 4. Then if x minus 1 is equal to 0, this gives us that x is equal to 1. So this over here are the two values for which the base is equal to 1. And of course, if the base is equal to 1, then whatever the value of the index is at that point, our left hand side of the equation will always be 1. Now, are there any other solutions to this? Here, are there any other solutions? Are there any other combinations of x and n to give us 1? Are there? Yes, there are. Remember that if you have two negative numbers multiplying each other, the negative will cancel to give a positive output. Okay, for example, if you have negative 2 times negative 2, you get positive 4, right? Then this space is a little cramped. Let me go over to the next page, sorry. Okay, I mean, if you have negative 2 times negative 2, you get positive 4. Okay, so you know that 1 times 1 gives us 1. So leveraging on this fact over here, we can safely say that negative 1 times negative 1 gives us what? Positive 1. Then if you raise this to any number, whether squared or cubed, it will still give us 1, because you're basically just squaring the both sides or cubing the both sides. It still gives us 1. And even if you don't want to think of it that way, what you are basically doing is, what is inside here is 1, then this is 1 squared, even if it's cubed, 1 cubed, all of them, it still gives us 1. So negative 1 raised to power an even number gives us 1, because this is just the same thing as saying like this thing we have over here is just the same thing as saying negative 1 squared, then raised to power anything, whether squared again or cubed, or you can even raise it to the 4th power, to the 6th power, to the 7th power. All these gives us 1. So since that's the case, we can safely say that our third condition is that whenever x, okay, let me just state it to avoid confusion. Okay, this is our base equation where we draw our reference from, is equal to 1. Then if x is negative 1 and n is even, then this gives us 1. Let me represent it more mathematically. If we have negative 1 raised to power an even number is a number divisible by 2, so 2 times any number is an even number. So negative 1 raised to power an even number, this gives us 1. So if we solve, we just have to equate our base to negative 1, then make sure that the values of x we get at those points, we make the index even. So if it satisfies this condition, then we are good to go. Okay, let's just do that. Okay, we have our base is x squared minus 5x plus 5. We are now equating it to negative 1. Then adding 1 to both sides of the equation, we get 6 over here and we get 0 over here. Then expanding, we have x squared minus 3x minus 2x plus 6 is equal to 0. Then we can just simply factor out x. We can factor out x. We get x minus 3 over here, and negative 2 come out. We get x minus 3 over here, and this is equal to 0. Now, since x minus 3 is here and here, we can simply factor them out. We get x minus 3 over here, then we get x minus 2 remaining. All these are equal to 0. Now, for this equation to be correct, it's either x minus 3 is equal to 0 or x minus 2 is equal to 0. That's x minus 3 is equal to 0 or x minus 2 is equal to 0. Now, this gives us that x is equal to 3 or x is equal to 2. Now, what you want to ask yourself is, okay, let's go back to our condition first. Now, this is our condition, and we said that for this condition to work, the base must equal -1 and the index must be an even number. Now, you need to ask yourself, are those values of x we got, will they really make our base to be -1? Yes, of course, it will make our base to be -1. Now, at the same time, will it make the index to be even? Now, that we don't know, because the index is an entirely different equation. So since we don't know, we just have to check, right? Okay, so what's our index again? Let me check. Okay, our index is x squared plus 4x minus 60. Okay, so let's use that. Okay, x squared plus 4x minus 60. Okay, so we need to make sure that this equation is even for these values of x over here. Okay, so let's do that. When x is 3, we have 3 squared to give us 9 plus 4 times 3. This gives us 4 times 3 is 12, and 12 plus 9, that gives us 21. Now, 60 minus 21, this gives us minus 39. And minus 39 is not even. So since it's not even, x is equal to 3, it's cancelled out. So now let's choose x is equal to 2. If we do that, we have 2 squared, which is 4, plus 4 times 2, that is 2 squared plus 8. That gives us 4 plus 8, 12, minus 60. This gives us -48. And -48 is actually even, because you can split it to get 2 minus 24. This is even, because 48 is divided by 2. So since that's the case, x is equal to 2 is a solution. Now, remember, we were told to get the sum of all real values of x. So just getting the values of x is not actually enough. We need to sum them up. So let's just take a moment to do that. Now, let's collect our results. Let's do that in the next page. Okay, so our values of x are -10, 6, 4, 1, and 2. Now, all that's left to do is just to sum this up. So we get -1 plus 6, that gives us -4, plus 4, that gives us 0, then plus 1, that gives us 1, plus 2, we get 3. So the sum of all the values of x that satisfies the equation is 3. I hope you enjoyed the video. Please subscribe to my channel, like the video, and share it to your friends. Thank you. Have a nice day.